Hello everyone, welcome back to Guru Academy. Today we're tackling complex numbers, question 1 from our paper. Let's go step by step. So we are given, on the first question, we are given Z1 equals to 2 minus 3i squared. And we want to simplify this, right? This is question 1.1.1. So step 1, we're going to expand the bracket. So I'm going to say Z1 equals to 2 minus 3i and another 2 minus 3i because of the square, right? Okay, and then we're going to say Z1 is equals to, let's see there. This is going to be, remember, we're going to say this times that and this times that, and then come with the second one and times again, right? So we can see that 2 times 2 would be 4. So 2 times 2 is 4. 2 times negative 3i, it's negative 6i. And then we go to the red now. Negative 3i multiplied by 2, it's negative 6i. Then negative 3i times negative 3i, it's positive 9i squared. Right. And we need to remember this, that I squared is basically minus 1, right? So let's now add like terms. Z1, it will be equals to 4 minus 12i, because minus 6 and minus 6 is minus 12. And then plus 9. The I squared will always change to negative 1. And we can see that we have Z1 equals to 4 minus 12i minus 9. Minus 9, because positive 9 and minus 1, it's minus 9. And then these two are also like terms. So Z1 becomes minus 5 minus 12i. And that is fully simplified. Now the next question is 1.1.2, and they want us to write Z1 in polar form. Okay. So now we want to rewrite Z1 in polar form. So remember, Z1 was minus 5 minus 12i. So in polar form, step 1, we firstly have to find the modulus. And the modulus is given by R is equals to A squared plus B squared. And this is given on your formula sheet. And then our A squared is the real part, which is minus 5. So this is your A, and that's your B. So it's A plus BI. Good. So it's going to be minus 5 squared plus minus 12 squared. And I'm sure you can see I'm putting in brackets. Then we can say R will be square root of 13. When we press our calculator, we get square root of 13 there. And then that is our modulus. Step 2, we need to find the argument or the angle, that is theta. And it's also given on the formula sheet is shift tan minus 1 B over A. And then we said shift tan B, we said is minus 12 over minus 5. Right. And when you press that on your calculator, it should give you theta equals to 67.38 degrees. But we need to be careful here, because remember, our point is in the third quadrant. I'm going to show you that now. Remember, we have Z1 equals to minus 5 minus 12i. So basically the real part is the x, and the imaginary part is the y. So which means here you basically have, you are in this quadrant here, the x value must be negative, which is here, and the y value must be negative, which is here, which means our arm will be somewhere here. Ne? And remember, this quadrant is 180 plus. Ne? So whatever theta we have, we're going to add it to 180 because we are not in the first quadrant. If we were in the first quadrant, we would leave it like that. Ne? But because we are in the third quadrant, we're going to say 180 plus. So therefore, theta would be 180 degrees plus 67.38. The reason I'm doing that is because in the third quadrant, it's 180 plus. Okay, in the second quadrant, it's 180 minus. In the fourth quadrant, it's 360 minus. Okay, sharp. So this will give us 247.38 degrees. All right, and then now, remember the Z1 in polar form is basically R cis theta, right? Which means Z1 would be, our R was root of, let's check. Was it root of 13 or was it 13 actually? I think I might have made a mistake here. This becomes 13 if you press it on a calculator, not the square root of 13. All right. And then this will be, our R is 13. So we're going to have 13 cis theta, which is 2. Okay, I like putting bracket here. 247.38. And we have written it in polar form. Okay, and then now we need to simplify the following expression, which is 1.2. So in 1.2, we have 3 to the power 5i minus I in bracket 2i to the power 3 plus square root of negative 9. So ladies and gentlemen, before we do this question, I want to discuss something with you. If I have I, it's like I have square root of negative 1, right? I squared is going to be negative 1. I3 is going to be negative I. These are the most important identities. I to the power anything, okay, this one, let's write it here. I to the power a multiple of 4. Multiple of 4. It's always 1. By multiple of 4, I mean like anything that is completely divisible by 4. For example, 60, 100, 120, 44. As long as it's I to the power a multiple of 4, your answer will be 1 always. And this is the most important identity that I want you to remember. All right, now let's come and simplify this. Let's come and simplify this. So if you see here, we're going to have equals to 3 to the power I to the power, 3 times 5, 3 times I to the power of 5. Then here I have minus I outside. So guys, here the rule is this. The outside exponent will always multiply the inside exponent. So we have 2 to the power 1 and I to the power 1. So the inside and outside exponents will multiply. So I have 2 to the power 3 because 1 times 3 is 3. Then I also have I to the power of 3. Then I close my bracket and then plus, here I'm going to have square root of 9i. The negative inside the square root just means I basically. So you replace it with I because look at here. You have minus 9, which is 9 times negative 1, right? This can be written like that. Do you see it? But square root of negative 1, it's I. That's why you can replace the I with that. And it has to be outside. Sorry about that. It has to be outside. Like that. Okay? Good. Now let's keep on simplifying. We're going to have 3 to the power I to the power 5 minus, if you check here, this and that will give us I to the power 4, ne? And the 2 to the power 3 will give us 8. So we have 8I to the power of 4 plus square root of 9 will give us 3. So we have 3I there, ne? So if I have any exponent that is bigger than 4, I'm going to write it in terms of 4 and something. For example, 3 to the power 5, I can write it as, this one, I can write it as I to the power 4 and I. You see? This is still the same as that. Ne? So any exponent bigger than 4, we have to represent it in terms of multiple of 4. This is what I mean, ladies and gents. Let's say I had I to the power 50. Ne? I would write it as I to the power 48 because 48 can completely divide into that, and then I to the power of 2. That is still I to the power of 50. Okay? And then minus 8I to the power of 4 plus 3I. Remember, we said I to the power multiple of 4 becomes 1. So which means this part here will become 1. So I have 3 times 1 times I minus 8 times 1 plus 3I, which gives me 3I minus 8 plus 3I, right? Which gives me minus 8 plus 6I. And that's it. We simplified Z1, we wrote it in polar form and smashed through a tricky expression, right? So, and remember these rules here, they are very important. Keep practicing and you'll master complex numbers in no time. Don't forget to like, share, and subscribe to the Seguru Academy. See you in the next one.